In 20 seconds, here's why machine learning is important. Business needs prediction. Prediction requires machine learning, and machine learning depends on data. Putting that in reverse, we have data, we give it to machine learning, it generates models that predict, and those predictions improve everything we do. They render more effective and efficient all the large-scale operations of organizations that make the world go round. In that way, we boost sales, cut costs, combat risk, prevent fraud, fortify healthcare, streamline manufacturing, conquer spam, and win elections. But isn't prediction kind of impossible? We don't have a magic crystal ball, right? The weather can only be predicted so far, so well, so far ahead. Human behavior, no less challenging to predict. How do we put credibility on a field that has the audacity to call itself predictive analytics? That's a credibility question I'll address partway through this video. So in this video, I'm going to talk about predictive analytics and machine learning, illustrate them. They're largely synonyms, but predictive analytics is a subset of machine learning. And I'll show how prediction delivers value, the value propositions, application areas of machine learning in business for targeting marketing, political campaigns, and many other application areas across industry verticals. And I will show some example predictive insights that we get, what the data needs to look like, and those serve as the building blocks for prediction. So a couple slides about me and my work. I'm the founder of the Predictive Analytics World Conference Series, which is the leading cross-vendor event focused on the commercial deployment of machine learning. We have conferences in the US and Germany. Our largest event next year will actually be online, so you can register at a lower cost and attend without traveling. It will be in May 2021, and this umbrella event will actually be called Machine Learning Week. It'll include 5 concurrent Predictive Analytics World conferences, industry-focused Predictive Analytics World for business, for financial services, for healthcare, and Industry 4.0. So those are 4, and then the closely related sister event, Deep Learning World. You can find out more about that May 2021 conference at predictiveanalyticsworld.com. And I am the instructor for the 3-course series, Machine Learning for Everyone, on Coursera that's totally free to access. So as a former academic, it's a conceptually complete end-to-end course series. The 3 courses amount to the equivalent of a college or graduate level course that covers both the technology side and the business side, and it's fully accessible and understandable to business level learners, and yet also vital to data scientists and budding technical practitioners, since it covers the state-of-the-art techniques, the business leadership best practices, and a wide range of common pitfalls and how to avoid them. You can see how to access the entire curriculum for free on Coursera by going to machinelearning.courses. So if you don't need this course, your boss probably does. So for business side learners, this is a comprehensive go-to because it covers these 3 things. Machine learning project leadership, the management process best practices for machine learning projects, generally not covered by typical technical machine learning courses. It does a survey of machine learning algorithms in a way that's substantive and yet fully accessible to all learners, and covers data preparation, which is a major bottleneck to being able to apply machine learning algorithms and machine learning software tools, and is directly informed by business considerations. And yet beyond this need that it serves for business side learners, the 3-course series on Coursera, Machine Learning for Everyone, is also a must-take for everyone involved in any way in machine learning, because it also covers these things that are generally not covered by typical machine learning curricula. A deep dive into machine learning ethics, including risks to social justice, explaining this whole question about equitable models and machine bias, discriminatory models. The end of each of the 3 courses have several videos where we do a deep dive on all kinds of issues in machine learning ethics. It looks at performance measures of predictive models in business terms, so business-oriented performance models. We look at the advanced modeling method, uplift modeling, which is very rarely covered by machine learning training of any kind. And we cover all these major pitfalls. These are the things that most often derail predictive modeling initiatives, but are very much informed by sort of business considerations and understanding the meaning of the models, what they're doing, and whether they're sound, what you've learned from the data is real. So these include p-hacking, and there's a deep dive on each of these. Each of these has 2 or 3 video series, each one of them. P-hacking, overfitting, what I call the accuracy fallacy, which I'll mention a little bit later in this video, presuming causation from correlations, and serious problems with overhype when we refer to machine learning as artificial intelligence, as is so commonly the case. And finally, I'm also the author of this book, Predictive Analytics, the title of which actually, if you look at the full subtitle, serves as an informal definition of the field. It's Predictive Analytics, the power to predict who will click, buy, lie, or die. So this book's used as a textbook at 35 universities, but isn't written as a textbook. It's very much in the style of pop science, anecdotally driven, lots of stories, case study examples to illustrate the concepts. Also fully accessible to all readers, conceptually complete like the course. If you prefer to see the movie, then read the book. Go check out the course at machinelearning.courses. They are somewhat supplementary. You can find out more about the book at thepredictionbook.com. So let's start by comparing predictive analytics and forecasting in the arena of political elections. So in the United States, there's no better known prognostic quant, no more famous person of prediction than political poll aggregator Nate Silver, who gained quite a bit of notoriety, in particular for correctly predicting for each individual state in the United States, the 50 states, the outcome of the 2012 presidential election. So here was Nate Silver's forecast, actually 2016, showing a 71% chance that Hillary Clinton would win. Many people saw this, since Hillary Clinton did not win, Donald Trump did win, saw this as a failing of the data, the polls, and or of the model. But in fact, a 29% chance of things going the other way is not a long shot. 3 out of 10 is not something that happens extremely rarely or should be considered a big surprise. And in fact, a 71% chance of winning is, the takeaway is not, well, she's almost definitely going to win. The takeaway is you're closer to a 50-50 toss-up than a 100% sure thing. So the takeaway is uncertainty, like, I don't know. The data doesn't let us be very confident here. There's a lot of uncertainty. As I mentioned at the beginning, prediction's really hard. In any case, what Nate Silver did is not predictive analytics, but actually at the same time what the Obama campaign did was predictive analytics. And this perfectly illustrates the difference between predictive analytics and forecasting. Nate Silver did forecasting. So for an overall state, this is the state of Ohio, he predicted what's the probability that state as a whole will end up going for one candidate versus the other. So for example, 2016, he showed a 65% chance forecast that the state of Ohio would go for Donald Trump. Whereas the Obama campaign in 2012, instead of these overall state forecasts, their analytics team rendered a predictive score for each individual voter. And actually, not according to this example of Democrat versus Republican. In the case of 2012, that would be Obama versus Mitt Romney, the outcome, the behavior, which direction is each voter going to go. But a more advanced predictive analytics method was applied to predict for each individual whether they're influenceable or persuadable, whether sort of marketing or campaign treatment, such as a knock on the door or a phone call, would change that outcome or behavior, the voting behavior. Similarly, targeting direct mail. All these things, these marketing treatments to drive outcome, to drive voting behavior, same concept very much applies to drive commercial marketing behavior. So in a nutshell, this very much distinguishes between forecasting and predictive analytics. Nate Silver used forecasting to compete very publicly. He was on all the talk shows in 2012 at the time. to win at forecasting the outcome of the presidential election. Whereas the Obama 2012 re-election campaign analytics team competed very unpublicly, unbeknownst to most people behind closed doors, not just to win at forecasting the outcome, but to win the outcome, to win the election itself. So which is more powerful, right? Predictive analytics, by virtue of that defining characteristic, a prediction for each individual, right? That's what distinguishes it from forecasting. And by virtue of that, those individual forecasts directly inform the action or treatment to be taken with each individual. And so in that way, it makes things run more effectively, efficiently. In other words, rather than only providing the ability to forecast the future, it's the power to change or influence what's going to happen, the future. Now, we have reason to believe that Hillary Clinton's campaign in 2012 against Donald Trump also did use predictive analytics. But even if they did, the degree to which it might have helped obviously didn't overcome other factors. She lost the election to Donald Trump. But in business applications of predictive analytics, you don't have the same kind of winner-take-all dynamic in general. In fact, businesses very much are jumping on the bandwagon. This is a huge and very quickly growing field, with the slightly broader field, sometimes referred to as AI, forecasts to arrive at over 200 billion by 2027. It's shown in surveys as the number one priority of chief information officers and LinkedIn's top emerging job, the number one slot in the US. So we can call predictive analytics, it's like Moneyball for money. So much so, people are calling it sexy. So the Harvard Business Review ran an article, 2012, Data Scientist, the Sexiest Job of the 21st Century, written by Thomas Davenport, who wrote the foreword to my book, and DJ Patil, who subsequently became the first chief data scientist of the US. So, I think these are two super handsome guys, but sexiest profession, I always assumed that was reserved for firefighters. And I don't know. I thought maybe it was the hard hat, So this is a picture of me dressed up as a data miner for Halloween. I hope that, that does the trick. Actually, firefighters use predictive analytics in New York City to target and triage, prioritize which buildings to inspect, which are at highest risk of fire. Similarly, utility company Con Edison in New York City does the same thing to target and prioritize the inspection of manholes for dangerous incidents such as explosions and fire. So to explore the effect on your social life of being a data nerd, we produced this 3.5-minute educational rap music video called Predict This, which you can watch at your leisure at predictthis.org. Definitely crazy, campy video, silly, but the lyrics are genuinely educational, the best ever educational rap music video about predictive analytics ever, until just recently we just dropped a brand new one called Learn This. It's in the middle of the Coursera course series, in the middle of the second of 3 courses, which again, you can register for free at Machine Learning. Go to machinelearning.courses. It'll tell you how and link it to access all the curriculum. As you can see, calculator watch, tape on the glasses, Star Trek insignia, Rubik's Cube bling, tracksuit pants. It's in the details, my friends. Here is a 57-second trailer for that new rap music video.
Watch the all-new machine learning rap music video. In a world ruled by data scientists, one realm lies beyond their reach. The dance floor. If the geeks shall inherit the earth, this cannot stand. But then, in 2016, a guy named Dr. Data broke through, dropping a bomb that freed these nerdy wallflowers and dancing his way to universal machine learning education. Now, he's back. Watch the all-new machine learning rap music video, part of Coursera's Machine Learning for Everyone with Siegel, the first and only educational music video on Coursera. Face the music.
This is the quintessential case of expectation mismanagement, because that overproduced epic trailer is totally inappropriate for what is a very campy little music video right in the middle of the 3-course series, Machine Learning for Everyone on Coursera. Okay, let's talk about, let's actually give a full definition of predictive analytics. It's technology that learns from experience. And by experience, I mean data. So data sometimes sounds like a boring or dry thing. It's a bunch of ones and zeros, a bunch of numbers or information. But that's because it's easy to forget that data is actually a list of things that have happened. It's a recording of prior events. It encodes the collective experience of your organization, from which it's possible to apply these analytical methods known as machine learning to derive a predictive model that predicts the future behavior of each individual. So each individual receives a predictive score, generally in the form of a probability, and the higher the number, the higher the expected chance that that individual will click, buy, lie, or die, as in the title of my book, commit an act of fraud, turn out to be a poor credit risk, et cetera, et cetera. Any and all top types of possible outcome or behavior in order to drive better decisions, such as who to target for marketing contact, fraud investigation, approving credit applications, et cetera, et cetera. And the word here, individuals, intentionally general, because it can also be individual corporate clients, products, manhole covers, buildings that might catch on fire, satellites whose battery are likely to run out soon, et cetera, et cetera. So it's such a universally applicable thing. Now, predictive analytics and machine learning are mostly synonymous. They both refer to the use of these machine learning methods: decision trees, naive Bayes, logistic regression, neural networks, ensemble models, and many, many others. These are some of the most well-known and often used ones. Predictive analytics is basically a smaller subset because it's certain business applications of machine learning. But in this presentation, I'll mostly use these two terms synonymously. It all falls under the umbrellas of big data and data science, neither of which are specific technologies or methodologies, or neither allude to any particular value proposition, but rather they allude to, they're subjective areas, but they allude to a very much a growing culture of smart people trying to do clever things with data to derive value. And the same thing can be said about the older school term data mining. So in a nutshell, the data comes in to the software tool that embodies a predictive modeling algorithm. You push go, and it automatically learns from the data. It generates this predictive model that I depict in these slides as a golden egg. And the whole thing, the thing that's learned is that model. It's the thing that can now score or make predictive probabilities for each individual. So now, what I've shown here is typically done offline, but now the predictive model is applied potentially in real time, depending on how it's needed, one individual at a time. See, for that individual, you take as input what are called the independent variables, the things known that might help predict, the things that I had access to during that offline learning process, the characteristics of the individual, any demographic and behavioral values about the individual that may help predict. And it considers them all together in concert to derive as precise a predictive probability for that individual as possible. And that's what the cutting edge science that we're standing on the shoulders of giants using for these business value propositions is. So it's going to provide the predictive score pertaining to that one prediction goal, whatever outcome or behavior you're trying to predict for that project, generally one model per prediction goal. So for example, in marketing, looking at a customer today, you're saying, hey, should I apply the marketing treatment? If I spend the money to contact them, to send them this marketing brochure, what are the chances that tomorrow there'll be a positive outcome. They'll buy our product. So the value proposition is clear, but as I mentioned, prediction is very difficult. What are we really talking about here? There is no magic crystal ball. Niels Bohr, Nobel Prize winning physicist, said prediction's very difficult, especially if it's about the future. And Jay Leno, the comedian, how come you never see a headline like psychic wins lottery? So here's the deal. It's really simple. The bottom line is you don't need to predict accurately per se. Predicting better than guessing is generally more than sufficient to deliver value and drive a tremendous impact on the bottom line. In fact, high accuracy is a very common oversell of machine learning. Here are some real headlines. AI can tell if you're gay. AI predicts sexuality from one photo with startling accuracy. Linguistic analysis can accurately predict psychosis. AI-powered scans can identify patients at risk of a fatal heart attack almost a decade in advance. And this scary AI has learned how to pick out criminals by their faces. So if you believe these titles, then you'd believe that it's possible to predict whether someone is gay, whether they're going to develop psychosis, whether they're going to have a heart attack, and whether they're a criminal, and predict for whom the answer is yes, and also predict for whom the answer is no, and usually be right about it. That's the implication, and that's a false implication. But it's a clear implication, and it's misleading. I call this the accuracy fallacy. You can Google for my Scientific American blog article on the accuracy fallacy. Now, some things can be predicted, like is there a picture of a cat? Is there a cat somewhere in this photograph? There's some things that you can get high accuracy per se. But the thing is accuracy is not generally the pertinent measure. And even if we can't get high accuracy, we get value. So here's a back of the napkin arithmetic example where we're going to show the value of predicting better than guessing, even though it's not accurate. And we'll talk about a metric that's more pertinent, more relevant than accuracy. So let's say we're doing direct mail to 1 million prospects. We've got this contact list with 1 million people on it. And everyone we contact costs $2. So without machine learning, without a model to help us target, let's just go do mass mail to everybody. We're going to contact 1 million people, $2 each. Obviously, that means we're spending $2 million. Now, if a single percent of them actually do respond and make a purchase, and we get $220 profit for each one, that means we get 10,000 positive responses, profiting us $220. That's $2.2 million in. So we spent $2 million, but we made $2.2 million, giving us a bottom line profit of $0.2 million, $200,000. How much better would we do with a predictive model? Well, let's say we took a small sample, 40,000 individuals, and we say, okay, let's test these out. Let's try the marketing out on these ones. We send the marketing, we wait around a little while, find out who did and didn't respond. That's our experience from which to learn. That's the training data. And if over those 40,000 we apply machine learning, get a predictive model, that golden egg, apply it over the entire list here of 1 million, right? And then order the list from most likely to respond down to least likely to respond, and then take the top 25%. The top quarter. Well, if the data is pretty good and the modeling method is sound, then maybe in that top quarter, the top 250,000, we'll have what's called a lift of 3. A lift of 3 because it has a 3% response rate. That is, say, over that smaller pocket, that hot pocket of top quarter, top 250,000, the response rate is 3 times that of the overall average of 1%. So that's called a lift of 3. It's a nice metric, useful, called lift. Well, now we're going to just do marketing just to that top 250,000. That is to say, we're going to suppress the other 75% from the mailing list, basically save 75% of the marketing costs. So that's good. That means, of course, we'll forsake some of the business we would have gotten from that bottom 75% of the list, but we've got a much higher concentration as top quarter. So now if we do the same exact arithmetic that I did a second ago, use your calculator watch to that top 25% with a 3% response rate, $2 per contact, you put it all in, it's just a little arithmetic, and you find that the bottom line profit skyrockets by a factor of more than 5 to $1.15 million as the bottom line profit from that marketing campaign. right? A dramatic improvement by driving 1 million yes/no decisions, right? We eked out with a predictive score for each individual, which of them we do contact and which we don't. And we're contacting the top 25%, but that's after ordering them. So we've essentially driven 1 million yes/no decisions, and only by more intelligently targeting, right? No new product or business ventures, not even a new marketing creative. We created such a dramatic improvement that I hired my graphic designer to draw this explosion star thing, right? I pay him by the hour, but that's how big a difference it is. But on the other hand, it's not accurate. We don't have high confidence about any individual. It's a 3% response rate in this hot pocket. We don't have high confidence that any individual is definitely going to buy. We just have this nice improvement in the overall response rate. So this model kind of totally stinks if we're thinking about the word prediction and what a magic crystal ball ought to be able to do. But no denying the value. So we can call this a skunk with bling. That would be the alternative definition to predictive analytics. A skunk with bling. Definitely write that down. So I call this the prediction effect. A little prediction goes a long way. Predicting better than guessing, generally more than sufficient for many of these value propositions, many of these application areas, to drive value and deliver a tremendous improvement on the bottom line. And this is just so generally applicable because we live in an inefficient world, right? Most mails, just junk mail, goes straight into the recycling bin. A large amount of email is spam. Financial institutions are blindsided by risky debtors and policyholders, right? So many transactions that are fraudulent never get caught. And yet, the vast majority of transactions that are audited for fraud are actually legit, and you didn't have to spend the time of an auditor. It's just life. It's an inefficient world. Business is a numbers game. And what we can do, and this is the only way to do it, is to tip the odds in our favor by playing that numbers game a bit better, by learning from data to predict. So the broad applicability of just the idea of learning from data is tremendous. So how does it work? Well, let's turn to a quote from Kung Fu Panda, where the old wise turtle, the mentor, voiced, of course, by Dustin Hoffman, said, "Yesterday's history, tomorrow's a mystery, but today is a gift. That's why it's called the present." Okay, so what do we have today? Taking a slightly less sentimental look at it, what resource do we have today that's going to be valuable to help us put odds on that ultimate unknown tomorrow? We're looking at the customer today, but we don't know what the outcome or behavior will be tomorrow. That's sort of the definition of the future. It's the stuff we don't know yet. Nobody knows. But we do have two things in pocket that we already know, which is that we know yesterday we applied the marketing treatment, we spent the money to contact this individual customer, and then we found out earlier today that there was a positive outcome. They bought the product. So these two things are both in the past. No prediction needed, but it's a learning case. It's an example from which to learn. It corresponds to this one row of data. Everything on the left of the dotted line is what you would have liked to have known, or I'm sorry, everything on the left of the dotted line is what you knew at the time you had to decide whether to apply the treatment. The customer was male, lives in California, had made at least 10 purchases, etc. And then on the right of the dotted line is the outcome. Happened later in time, but at this point still in the past. This is one row of what's called the training data. And when you get a bunch of rows like this together of these learning examples, these training examples, training cases, that's the form and format, that two-dimensional table that you got to get your data into in order to use machine learning. For any of the machine learning algorithms, any of the predictive modeling methods, that's the same thing, as embodied with any of the analytics software tools. This is a specialized task, generally considered to take 80% of the hands-on portion. That's a general rule of thumb. It's not the rocket science part, but it's always a specialized, customized database programming, data manipulation task depending on how your data looks and the origin that you're pulling your data from. But once you get it into that form and format, now you can actually leverage the value of data. And you get all these insights, such as people who go to bars are worse credit risks. Canadian Tire issues credit cards, and then they look at who pays their credit card bill on time relative to how they spend, what they're doing with their credit card. And it turns out that people who are observed spending at a drinking establishment are higher credit risks, whereas individuals who are seen spending with their credit card at the dentist are generally, on average, lower credit risks. And finally, those who purchase the little felt pads that go at the bottom of your chair so you don't scratch the floor, lower credit risks. People who like curly fries on Facebook are more intelligent, and this is not necessarily because curly fries make you more intelligent. But it's supposed that there was a Facebook page for curly fries, and then some intelligent people liked it, and then their friends liked it, and there was a network of relatively intelligent people who were liking it. Right? So you see these trends that are useful for prediction, but don't necessarily relate to causation. Similarly, men who skip breakfast are at a higher risk of coronary heart disease. Again, not necessarily caused directly by any like health benefit of the meal or of the food, but rather it's considered a proxy for lifestyle. So people who are in a rush, live a hectic, fast-paced, high-stressed life, more likely to skip breakfast, also more at risk for coronary heart disease. Finally, certain neighborhoods of San Francisco, this is San Francisco, I don't know if this is one of those neighborhoods. This was reported by Uber, showed that certain neighborhoods of San Francisco that exhibit higher rates of crime also exhibited higher demand for Uber rides. Uber took down the blog entry, but on the internet, you can't actually delete anything. In any case, their hypothesis had been, and it seemed to pan out from the result here, not that it's the criminals riding in the Ubers, but that those neighborhoods are where there's a higher proportion of non-residential population. That is, those are the areas of the city where you have more people going through it who don't actually live there. So I call this the data effect. Data is always predictive. For all intents and purposes, you get your data together into that tabular form, the training data, so you can do the analysis. And you're going to always find these kinds of predictive insights. And they each serve as a building block for that golden egg predictive model, which serves to consider multiple factors together in concert to help improve the predictive scoring. And then you deploy it. You make use of it. You drive operations such as in marketing where you get this benefit. First Tennessee Bank showed a decrease in direct mail costs by improving with machine learning of 20%, which resulted in an improvement to the return on investment by a factor of 6. Large retailer in the United States, Target, does target marketing. They improve the direct mail by 15 to 20%. And Premier Bank Card, a major issuer of credit cards, reduced their mailing costs by $12 million. Now, for us as consumers, this is really an antidote to information overload, because now you're scoring these information pieces as content items. For example, in search results, which one should I see first? I do a Google search. There's so many potential responses. I'm only going to look at a very small number of them, relatively speaking. And indeed, Google search does use machine learning to help optimize the order of the search results. Very similarly, the default order of your news feed on Facebook, right, of all the thousands of posts of your contacts in relatively recent time, which one should be shown first, second, third, etc. Predictive scores. Same core technology, machine learning filters the spam out of your email inbox. In that case, extremely effectively, as we know. They've almost essentially solved the spam problem. And then very much analogously, product recommendations, right? Of all the content items, How are you going to choose which movie to watch, music to listen to, products to buy on Amazon, books, etc.? When you do a search in Airbnb for a potential rental, to rent a place to stay, the results are ordered in a way that's customized or personalized for you according to your profile and behavior, right? Using a predictive model developed from machine learning. Our experience in modern day society is dictated by how we're treated and served by organizations. And they are driving these decisions about what to do for us and what to do unto us with machine learning, with predictive scores from the model developed by machine learning, more and more across all industry sectors, business, financial services, education, government, law enforcement, and very much healthcare was another hot area. We're talking more about business applications today. It affects everybody every day. Millions of decisions are driven every day by organizations, and these are the verbs of the things they're doing for us and unto us, the way we're treated and served. Millions of decisions are driven by those predictive scores, determining whom to call, mail, approve, test, diagnose, warn, investigate, incarcerate, set up on a date, and medicate. So I like to call predictive analytics the latest evolutionary step of the information age, where we've moved from the application of engineering to warehouse, collect, and manage bigger and bigger data. From that engineering now to the application of science to learn from that data's content, what it means. And what do we want to learn? We want to learn how to predict as effectively as possible, because predictions are the most actionable form of analytics, right? They directly inform those decisions about how to treat, serve, and what treatment to apply for each individual, rendering all the mass scale operations that we conduct as organizations more effective. So the Harvard Business Review calls machine learning the most important general purpose technology of our era, and famous machine learning professor Andrew Ng calls machine learning the new electricity. So if you want to keep learning more, there's a great deal more you can access with my Coursera course series, Machine Learning for Everyone, which and you can go to machinelearning.courses, which will give you sort of a lot more info about it and some details on how to actually access the entire thing without paying. If you want to get the certificate, that's where you pay. But all the content's there, accessible to you. There's it's well organized. You can look at the modules. It's a hierarchically organized 3 courses of 4 to 5 modules each, of several lessons each, of several videos each, and then a bunch of optional readings. A lot to look at there. So, machine learning is so generally applicable, right? Just this idea of learn from data to predict. It applies for so many large-scale operations across so many sectors, so many value propositions, that is to say, so many application areas. It's growing extremely quickly, and it works because of those 2 effects I mentioned, right? The prediction effect, a little prediction goes a long way. Predicting better than guessing, generally more than sufficient to drive value and have a great impact on the bottom line. And the data effect, which is that for all intents and purposes, data is always predictive. You can sleep well at night, put your data into that training data form and format, that knowing that when you do the analysis, you will find all sorts of predictive insights, that is to say trends, essentially, that can be then composed together with a golden egg predictive model to improve the predictions. So thanks for watching, and happy predicting.